exit presentation mode. And actually, let's load something else. I'm creating my thing for assignment 4 because we never gave solutions to assignments 3 and 4. I'm assuming that assignment 3 was incredibly easy and you're not, right? Is that correct? Or do we want to cover assignment 3 too? Looking at another version. That way we get a blank assignment 4 and we get to play with it, right? Okay. So we have read within range. You get a scanner, a print stream, and then low and high, right? And you need to ask the user for a number and eventually get a number between low and high, right? So, okay. Let's ask the user for a number. How do I do that? Out the print line, right? Right? And then we read that number. Int number input. What do you guys want to call this variable? Number. How do we read? Int dot next int, right? That gives me an int, right? And I'm reading from int because that's the variable name. That's this current that I'm giving out, and I'm sending stuff to out because that's the print stream that I'm given, right? Now, if the number is good, how do I verify where the number is good? Yes, it's greater than or equal to low and less than or equal to high, right? Then what do I return?
The number.
Life is good, right? Otherwise, what do I return?
Return
The same thing, right? And this is one of the few cases where you actually don't change this stuff on the recursive call because the change is coming from the new user input, right? Normally we do change. Any questions? I'm seeing the gears turning in some places. Questions? No? No questions? Cool. String times. Return the string repeated a bunch of times, right? This is basically power, right? Almost factorial, right? It's basically power. But instead of multiplying by the base, we are adding one string, right? So what's our base condition? When do I know how to stop? What's the simplest thing you can ask me? Then I just return, what do I return if times equals 0? Right? Otherwise, what am I going to return? I add this string and concatenate it, right? Or add it with now times minus 1, right? Does this make sense? Is prime. And this one kind of got a few of you in trouble, right? How can I know if a number is prime?
The half of the number and the divisible. The divisors.
Okay. A prime number is only divisible between 1 and itself, right? Every number is divisible between 1 and itself, right? So what I need to do is to test every other number, right? And if I test every other number and it doesn't divide it, then the number is prime, right? Now, do I need to test every other number? That's an infinite number of numbers, right? How can I make that set finite, right? Well, if the number is bigger than n, right? N number bigger than n cannot divide n, right? So a very simple thing is to test every number between 2 and n minus 1, right? And if that number divides n, then we know that n is not prime, right? So we are basically just counting, just like we counted in a bunch of other examples, right? Does that idea make sense? Cool. So, continue. Don't stop sharing, ever. So, do we want to count up or down? Do we want to start from 2 and count up, or do we want to start from n minus 1 and count down?
From 2.
Up. Okay. So when are we going to stop? When last tested, right, is n, when last tested is n minus 1, right? So if last tested, and I'm actually using last tested, I'm using it as last tested, right? If last tested is n minus 1, then I return true, right? Otherwise, if you gave me the one that you tested last, so I'm going to add 1, right, to get a new number, right? If it divides n, then we know that n is not prime, right? So what do we return? And if neither one of these is correct, then we return is prime of n and last tested plus 1, because that's the number that we just tested, right? Does this idea make sense? It almost makes sense, right? It's almost right. You could have, like many of you actually had really number to test rather than last tested, right? That actually makes this slightly easier. You need to reach n, and then we need to start here, right? And so what does this is prime would return? The way that we wrote it, right? We need to call the other is prime of n, and what's our last tested? With send n minus 1, we are counting all, right? With send n minus 1, it will return true, right? So we need to send, well, if you are using number to test instead of last tested, then it's 2. We are sending last tested, so it's 1. So when we test this guy, we start with 2, right? Does that make sense? You can set up your function slightly different, and then you're sending something slightly different. Does that idea make sense? This is almost correct, except for the fact that it would not work for 1, because by definition, and let me do this just for paranoia, by definition 1 is not prime. Why? Because mathematicians decided that 1 wasn't prime, right? It sort of satisfies the definition. It is divisible by itself and by 1, right? But we decided that no, we don't like it for a variety of reasons, right?
But we don't mention it in a first function.
Oh, you could, right? But if you do it here, right, then you are testing it every time you call the recursive thing. Whereas, right, and you know that it's not 1. So.
And I actually don't understand very well wrap over other recursive function. It's a bit.
It's actually, here's the deal, right? And these things may be, the idea, first of all, you can change names here, right? Does that make it less confusing? Is that what is confusing you, or is it? Let me do this.
It's like calling one function from another.
I mean, by now, right, you should be able to call one function from another, right? That's we have been doing that 10 times, right? You're just calling another function, right? The idea of the wrapper is that many times in your recursive functions, you need to pass extra parameters, right? We need this last tested parameter, right? That our actual client, the people who want to call is prime, don't care about, right? fact, they would need to know whether they pass 1 or 2 or n minus 1, right? Depends on how we write the recursive function. So we don't want to, that's an implementation detail, something they don't need to know, right? In fact, we don't want them to know, because if not, right, if they call it with 25 instead of 1, now my function doesn't work, right? So we don't want to give them a chance to screw up, which is why we create this wrapper.
So the both answer is same. We just
What do you mean both answers is the same?
the answer of the first function is prime recursive. It gives us the answer, but we use wrap for make it easier. Just get rid of the last step.
Yes.
But it will still give us the answer.
Almost, right? In this case, think about it, we're actually making it return false for 1, whereas this one would return true for 1, right? So we are using the other one, right? In that sense, but it doesn't necessarily give me give me the same answer, right? I'm using the other one. And that is a very common thing to do with recursion, right? Because many times you need that extra parameter. Sometimes you need more than one extra parameter, kind of either what's basically a looping variable or an accumulator, right? Those kinds of things can make your recursive functions easier, but you don't need to export that detail to the outside world.
So would it be wrong if we were just to use recursion to write that function instead of?
To write this one?
Yes.
How could you?
What would it be?
Yes, what would it look like? I mean, it would be perfect if you can. The thing is, you cannot, right? You cannot, because you need to keep track of where are you looking at, right? You cannot. You need this other guy.
Can we use a for loop here, or is it?
You can, in general, for this assignment and for the test, you cannot, because I want you to learn recursion and I want you to demonstrate that you know recursion. Assignment 5 actually asks you to do all this stuff with loops. So it's almost the same as assignment 4, but now with loops. I think I added 1 or 2 more or something like that. But for this, no, you cannot. You have to do recursion.
If we didn't have the wrapper, you would start with if n equals 1 and then if n equals 2 and then put the recursion.
You could do this, right? You don't need to. You could put it here instead of. You still need the wrapper, right? I mean,
So the wrapper is necessary.
the wrapper is necessary because you want to pass it 1 number instead of 2. The wrapper is necessary because right? I'm the client. I'm asking you if a number is prime,
I mean,
right?
In main,
In main,
function, we can do 1.
that's why you need the wrapper. You need the wrapper so that in main function, or in whoever calls you, it doesn't have to be main, right? This may be a piece of another function that calls 7 other functions, right? Doesn't have to be main. We normally show it in main, but so that caller can call you with 1 argument, right? That's why you need it.
Without the wrapper, we can't. do it.
Without the wrapper, that function doesn't exist, so you need to call this function, and this function takes 2 arguments, right? I mean, does that idea make sense?
So sometimes wrapper help the main function to give the answer, but sometimes just simplify it.
A wrapper is a function that whose basically its main purpose is just to call another function with a slightly different interface, right?
But it makes it easier to call the second.
it makes it easier to call the second function, right? It provides a slightly different interface.
How we can recognize we need wrapper? If in the midterm you give us just something ask us for write a recursion, how we can recognize
You don't recognize that you need a wrapper. What you recognize is that you need another parameter, right? I mean, in reality, if on a test or on if I'm a client that I'm asking you, write this code for me and I'll give you $50, right? I'm gonna ask you to write this stuff. This is what I want. Want to give you a number? You tell me if it's prime or not, right? So what you recognize is, oh, with recursion, I cannot do this directly. I need a function that has an extra parameter, right? And then if you need that function, well, you also need to provide the wrapper.
So it means all the recursion functions, if they have an extra parameter, we need wrapper for that?
Yes, if they have an extra parameter with respect to what the client wants. Sometimes you can do it like this, right? Well, in what the user is going to pass me, it has the extra parameter anyway.
But the extra parameter then has a basic. We know the basic in the prime is 2 or 1. So we need wrapper. But otherwise, just times and we don't have basic for that. It can be any number, so we can't have a wrapper.
Yes, if you don't need the extra parameter, then you don't need wrapper, right? And sometimes we showed an example or two where we use an accumulator, right? And so you actually have to provide a wrapper because you just created an extra variable. Depends on how you implement. There's several different ways of implementing the same thing. And so if your implementation has extra parameters, then you need a wrapper.
So this passing the same function name, I heard there's something overloading, but I don't know what is that.
Okay, overloading is that I don't really need to name these functions with different names. Look at this function. What's its name?
Yeah, so that is called data no, function overloading.
That's called function overloading. Yes. You have the same name for two different things.
Only Java allows it?
Most languages now do. Like C doesn't, but C++ does. All the C++ languages do. Python does. Ruby does. I think every modern language does. In fact, most other languages other than Java also allow for operator overloading. So you can define plus for your data types, which is good and bad. Sometimes makes your code much nicer. Sometimes makes your code horrible because you define something that doesn't really make sense.
In this example, the finding a prime number. So if you are doing from n-1 to 2, so is that a function overloading? Because from 2 to n-1 it takes faster, right?
But you can't. It's not going to be faster. It's going to be about the same, except that we are going to start optimizing. But the thing is, you can't create another one, right? Overloading happens because the number of parameters or the types of parameters is different, right? If not, if you try to define another one, with the same parameters, it's going to tell you, no, you can't. I don't know which one you mean, right? There is no way in here to know which one did you mean to call, this one or this one.
I mean, for going by the logic, we were like...
It doesn't matter. It's not the logic, it's the name.
Okay.
Right? I can change the logic here, and this one I'll return false always. Right? The problem is that in this call, and actually in this call, it doesn't know which one you want to call, this one or this one.
No, this is clear. So I was asking about like if it is from n minus 1 to 2, will it be overloading? No.
No, it wouldn't, right? It would be a different function or something like that, right? Overloading means two functions with the same name, two different functions with the same name. And the overloading happens with the different parameters.
Okay, I mean, the last day we saw about the age, we wrote two programs for that, two functions for that. The age 12 to 19 is a teen. So
Yeah, but if you notice, we changed the name of the functions.
First time we used the same name, then we changed it.
Yes, that's why, right? You can't overload if you have the same parameters. So when you change the names of the functions, there is no overloading, right? Does this make sense? Yes. Now you understand wrappers, you understand overloading. Cool. Can we make this slightly better? We can by doing this, right? It'll probably work. Actually, this is what we had, right? Let me actually go make sure that it actually works. Always a good idea. Okay. It works, right? We're getting 75 because we haven't implemented the other one. We should have done it after each one. And if not, you would have seen me sweat, right? The problem if you do this, you don't test it after everyone, is that stuff blows up because you forgot a semicolon. Now you don't know where the problem is, right? Now, if I do last tested, yeah, this should work, right? Yes. So we can do n over 2 and that divides in half. We can do even better by using SQRT. Right? If you get above the square root of, and actually, if we do this, we can do greater than or equal. Right? And that's kind of a math trick, not a programming trick. Right? You only need to test the square up to the square root, because then the divisors are going to start pairing up. Right? The numbers, like if you have 100, right? 2 is a divisor, but 2 pairs up with 50. So you only really need to go up to 10, because when you find 2, you also find 50. Does that make sense? That's a math trick, but can make your code slightly faster, maybe, depending on what you're doing. Let's make sure that we didn't mess it up. We'll try to make sure. My unit tests are not perfect. Oops. That's why I was saying that. Oh, no. Which one failed? Oh no, that's. Yeah, it was for small numbers. It was actually testing n. For 2, it would test n. first, right? So I need that other thing needs to be there first. Yeah, and I need greater than. Print FizzBuzz, right? You just need to count again, right? And I want from and to, right? So my ending is when from is greater than 2, right? Other than that, I'm going to print out.println FizzBuzz of from. Depends on, yeah, because we need to go that way, right? And then print FizzBuzz from +1 to out. Right? Yay! And I passed all my tests. Does this make sense? Any questions?
The first question,
This one, read within range?
you wrote notice I'm passing the scanner and
Yes.
into stream to
What that meant, right? Use this and this. Don't use, if you do system.out, right? Then my tester may not work, right? The actual unit test would not work because I'm reading this stuff on out, not on system.out, right? And if you had done scanner just in equals new scanner, if you do this, right, it would work on the screen, but it would not pass my tests. Because I'm actually passing you something that's useful. Even after that comment, there were at least 2 or 3 people whose problem was that they were trying to read from system.in or write to system.out. Many of you actually implemented FizzBuzz again in here. It's like, why? But it's perfectly okay.
You don't scroll it down to FizzBuzz.
FizzBuzz or print FizzBuzz?
Oh, yes, perfect.
Any questions? No? Cool. Let's... I will try to post one more example, but if not, let's go coding bat and find more examples, right, for recursion.
Excuse me.
Yes.
So what kind of return type we can do return now?
When you're returning objects, so if you're returning a string, you can return null.
Just for this for now.
For now, yes, only strings, and I don't think we ever do, but you could. Null is actually a value.
Can you do the function how many times a specific character is in the string?
Yeah. Didn't we do that one? No?
You're supposed to, but I think
Okay. Do we want to do it with, actually, let me save this and then go look at other stuff, right? File, open recent CS5K samples. This method. We're doing this, right? How many times okay, let me steal this tree. Create a new class. Feb15. So we have is empty head and tail, right? Number of occurrences. So how many times does the character appears, right? We can do it with is empty head and tail, right? And then we'll do it by counting too. So if is empty, if the string is empty, how many times does the character occur? Right? Now, if the head of the string is that character, right? How many times does it occur? We know at least once, right? One, and then, but we don't know how many times it occurs on the rest of the string, right? Does that make sense? Wouldn't it be cool if we had a function that tells me how many times a character appears on a string? Well, I do, right? And how do I get the rest of the string? Tail, right? So 1 plus number of occurrences of tail of s. And otherwise, if it's not there, right, then number of occurrences of tail of s and actually c. Does this make sense? This will probably. Public. So we would expect 2. Expect a bunch and 0, right? With some luck, it actually worked. We got 0 at the end, which is good. Yeah. 2, 7, 1, 2, 3, 4, 5, 6, 7. do we want to do it by just counting and using carat? Yeah. Let's do a cooler example. Was it this one? Pair star? No. No, that one is also fun, but let's do count pairs. No. Parentheses, something like that. There was nest parent. Given a string, return true if it's a nesting of 0 or more pairs of parentheses. Right? Let's do it by counting. Well, and again, yeah. If we are going to count, then we need, right? So we are going to check whether it is a nested parenthesis from that starting point, right? Does that idea make sense? When do we stop checking? Or, well, what are we going to check, right? We are given from the third character on, from the character number 3 on, right? So what do we do? How do we check whether it is, right? That character needs to be what? The character that we have needs to be what character? The open parenthesis, right? And the matching one needs to be the closing one, right? How do I know which one is the matching one? Count from the back, right? How can I count from the back? Well, get the length and subtract, right? Does that idea make sense? So if str.carat of from is not open parentheses, right? Return false. Let me do this for now. We'll come back to this in a second. And then, how do I know that I'm done? I could go all the way to the end of the string, right? I'm doing double work because I'm checking twice, but. So if from is greater than or equal than str.length, remember that we start at 0, right? Otherwise, return nest parent str from +1, right? The only thing that we need to do is this. Is that the right way? No. Actually, I need one less, right? Because if the length is 4, right, the last character is 3, not 4, right? So I need length minus 1, minus from. So this one would probably work. So we should see what? True, false, false, right? Oops, it doesn't work. Something is wrong. That should work, right? Should, except when it doesn't. We can debug. We can print stuff, right? And then we'll see what the heck did we do. Let me actually delete this other guy. Oh, I cannot actually keep going because then I need to start, right? I have to stop in the middle. I was going too far, right? 0, 1, yeah. We just need to stop at 2.
Why 2 instead of 3?
Sorry?
Why 2 instead of 3?
Why 3 instead of 2? 0, 1, when it gets to 2, right? That character should not be this, right? Because it's already... Oh no, never mind, because we have 3 open parentheses. 0, 1, and 2. So when it gets to 3, it's wrong, right? So we need to stop at... maybe. This one should work now. This one should work now. No, this should work, but it should be here. Ah, nothing works. Nothing works. That's not going to be on the midterm. Okay. Yeah, from greater or equal than str.length divided by 2. Yeah, the problem is that that's gonna That we can fix in a different place. One problem with this, do we need a wrapper for this function? We do, right? So we don't have to be passing this extra 0, which is ugly. Does that make sense? In fact, in here, we have it with only one thing, right? Does this make sense? So now we can change this guy, except that we are gonna see that we are also messing up one more thing. Maybe. I think we may be having another of y1 error. Yeah. Don't you like this thing? I just created it. Aesthetic. We are getting, we don't know, we are not dealing with this guy, right? So in here we can say if str.length %2 now our functions work. The wrapper also allows you to do those kinds of cheating rather than thinking, right? If the length of the string is odd, then you don't need to, right? Isn't this cool? No. What do you mean?
Something we have to know about ASCII and Unicode, because you mentioned that we already talked about it, but we haven't.
We have talked about ASCII and Unicode a bunch of times, but let me tell you again, we have. We have mentioned ASCII and Unicode, right?
First session?
Maybe. I don't know. If you go through the videos, but we can talk about it again, right? Basically, computers don't know anything about letters or strings. They cheat, right? All they know is numbers, right? All they really know is numbers. So we came up with a cheating way that says, okay, let me assign a number to each character, right? So we make the original thing, actually, God, the original thing was LCD or something like that. The most common thing that still gets used today is ASCII, right? ASCII mapped characters to 7 bits, right? The first 128. Why? Because English has 26 letters, right? But you need upper and lowercase, so that's 52. And then you need periods and semicolons and stuff like that, right? So they came up with 128 characters, right? Fancy letters. You need actually digits, right, and periods and stuff like that. So they came up with 128. Does that make sense? That's ASCII. ASCII 1, everybody agreed to use ASCII, right? Except that, and you can convert, right? You can convert a character to an int in Java directly, right? Just cast it and it will become an int, right? So in Java, you can have int A and you get 97, which is the ASCII code for A. Does that make sense? And you can actually do car of 97 and you get a letter.
For that function, you try 1, 2, 3, and you got a string 1, 2, 3. I try a very big number, and I got like a Chinese character.
Eventually, I don't know which function, right? I mean,
Two string.
this one. Probably not. Int. We have into digit and into string, into decimal string. That's the reverse, right?
Oh, there was something as I just put return char and then n.
Well, if you just return, right, here's what happens. It so happens that, terribly surprising, and I'm sure that you all will be terribly surprised, right? The US is not the world, right? And so ASCII is not enough. 127 characters, or 127 values, 128 values, sorry, were not enough, right? Chinese people need 65,000, right? Arabic people need different things, right? So we started doing horrible things. Most of the European countries said, well, ASCII is close enough, right? And if you do French, you have A with an accent and the other accent and the weird hat and those kinds of things, right? I don't know French. I know Spanish. In Spanish, we only have one accent, so you need 5 vowels with accents and the weird tilde for the ñ and a couple of other weird symbols, right? So people just said, okay, I'm going to use the numbers from 128 to 255 for my weird characters, right? So the French said, well, 132 is the A with this accent, and 133 is the A with the other accent, right? And so on. And everybody created kind of their own version of extended ASCII. And they didn't really agree, and so the French were using 132 for the A with an accent, and the Spanish A with the same accent ended up being 145 or something like that, right? So it was slightly messy, but sort of kind of worked. For non-Latin languages, right, it didn't work, right? There's languages, and Chinese is kind of the biggest example because they just happen to be 20% of the world. That doesn't match, right? You need a heck of a lot more. And so Unicode gives you that ability of doing a heck of a lot more. Java by default deals with Unicode characters in strings. And so what happens is if I do, and we can do it here, if I do car, actually the first 30 are non-printable. But if I do 120, right, I get X. If I do 140, I probably, well, I get nothing. It's the Unicode equivalent of this number. I have no clue what's the Unicode equivalent of that number, right? It just works for digits. For digits, you know that in every same encoding, the digits go 0, 1, 2, 3, 4, right? So if I subtract 0 from, so if I do 6 minus 0, right? That's going to give me 6. Does that make sense? And if I do 0 plus 5, what's this going to give me? The letter 5, right? If I convert it to a character, I get 5 as a letter. Right? The ASCII, I got 53, which is the ASCII for 5. When I think of it as a letter, it is the letter 5. So that makes sense, it's the character 5. But if you put something that's not in there, then you get horrible Unicode characters. Sure. That is actually a really cool question. I have no clue. You all are, most of you are not from here, so you probably know a heck of a lot more languages. And some of you, we're talking, right, 4 or 5 languages. I don't know whether Urdu or something like that uses something like a Latin character. How many letters? Who spoke Urdu here? Or, no? Not Urdu?
I speak Tamil.
Tamil.
Little bit. He speaks Tamil.
He speaks Tamil? Does Tamil uses normal, or how many letters? You use like Sanskrit or?
Yeah, it's same like Sanskrit. It's like 20 around letters.
Okay. So it's the same kind of stuff, it's just different letters. Right? Or,
There are many.
but
247 characters.
But you have accents and weird thingies on top, right? No? Okay. So different languages have different stuff, right?
Yeah.
If you know, you'll figure out, right? I know Spanish, so I know the weird accents in Spanish. I know that the French use different weird accents because my son is learning French. And I'm going to learn French.
Bonjour.
One of these years. Bonjour. I don't know anything. I was going to try to say good night or good evening. But bonne nuit is good night, right? So it's bon something or another. Okay. Shall we try to do one more from Coding Bat, or do you guys have any other questions? Or shall we?
Do you have something like this term?
What do you mean?
Code and you have to put
You may, right? It's right. You don't need to know. You just add 0 to it, and it becomes addition, right?
I add 1 and then it shifts the number. I don't know why.
Because that's the ASCII. That's how the ASCII table works, right? We have shown this, right? The ASCII table has that stuff. This is the actual number, right? And this is the character. All of these are non-printable until you get here. 32 is space, and then you start having other things, right? So if you get 45, which is a comma, you add 1, or sorry, 45 is a period. If you add 1, you get, what's that? Weird comma? Yes. 46 is a period, right? So if you add 45 plus 1, that's what you're going to get. You don't need to memorize this, right? But you do need to know, or it's a good idea for you to know, that the letters are contiguous, right? A, B comes after A, and it's 1 more than A, right? So I can do what am I going to get if I do this? A plus 1. It's going to give me what? It's going to give me B, maybe. I need to eliminate this guy. Right? And if I get capital A plus 1 is going to give me what? Capital B. Right? You don't need to know the characters. Right? You don't need to know the table capacity or something like that.
In your function, you can put 0 and then see the 0 string because for the base test you put if number is 0, return empty space.
Yes, the function yes, that would be something that you put on a router to treat with that special case. Because you need to distinguish when the function is called with a 0 and whether you're doing a 0 in the middle. So yeah, that's also another good use of routers. Yeah, I'll probably, yeah. I may not ask, but I'm not going to tell you to not study it. I'm not going to tell you not to learn. I'm not going to tell you not to learn, though. Right? But you guys should be okay, right? If you did the assignments, we have done a bunch of examples, right?
So the problem is not for the midterm you show us last session and the assignment. It's not gonna be something behind
No.
those.
No. I mean, the thing is that it's not one of those questions necessarily, right? Chances are there's not one of those questions, right? Because that's the point. I'm just programming. I can change stuff, right? But it's not going to be something terribly complicated. You don't need to, for an assignment, I may ask for harder stuff, right? For a midterm, it should be reasonably, if you know this stuff, it should be okay. Don't fret, don't over stress, right? Study, but don't over stress. It should be easy.
Data structure midterm too.
Yeah, as of next week.
Oh, now over stress on that one, but no, don't over stress. Study, but don't over stress. This midterm should be obscenely easy if you're taking the data structures midterm. Cool. Then I will see you guys on